In this AstroPictionary Math problem, we want to solve for the density of a solar system moon, namely the moon Hyperion of Saturn. We're given the mass is 5.62 times 10 to the 18th kilograms, and its size is 360 kilometers by 266 kilometers by 205 kilometers. So it is clear that based on the dimensions we're given for the size, that they think the shape of a Hyperion is that of a cuboid. It's not a cube, it's more of a rectangular cube, so it's a cuboid. We want to find the density in units of grams per cubic centimeter, and we want to find out if this moon can float on water at sea level of Earth, somewhere around the equatorial region where water is liquid. We're given the equation of density as mass divided by volume, and so we can just go ahead and substitute in. We're given the mass is 5.62 times 10 to the 18th, so we've got density is equal to a numerator and a denominator, 5.62 times 10 to the 18th kilograms in the numerator, and then the denominator we have 360 kilometers by 266 kilometers by 205 kilometers. So let's go put this in our calculator. So we type Google Calculator in Google and we get our value, and we plug in 5.62 EE18. Let's confirm. 5.62 EE18 divided by 360 and 266 divided by 360 divided by 266 and divided by 205. We get a value of 2.86. So let's carry that down. 2.86 times 10. Now we have to count the number of digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 10 to the 11th kilograms. And we have 3 kilometers in the bottom, and that is kilometers cubed. Well, we don't want kilograms and we don't want kilometers, so we're going to build our railroad track. We're trying to find our values in grams per cubic centimeter. So in 1 kilogram, we have 1,000 grams. And then we need to take care of our kilometers. So in 1 kilometer, we've got 1,000 meters. But we don't want meters either, so we need to build another railroad track to get out of meters. And in 1 meter, we have 100 centimeters. But if you notice, we have cube meters, so we need to cube everything. So 1 kilometer cubed, 1,000 meters cubed, 1 meter cubed, and 100 centimeters cubed. Now let's go ahead and divide out. This value, 2.86 times 10 to the 11th, is already in the calculator. We need to multiply by 1,000. So we multiply by 1,000 equals, and now we need to divide by 1,000 cubed. So we divide by parentheses 1,000 x to the y cubed, close parentheses, equals. And now we need to divide by 100 cubed. So we divide by, open parentheses, 100 x to the y cubed, close parentheses, equals. We have a value of 0.286. 0.286. And our units are grams per centimeter cubed. Let's check our units. It's always nice to check the units to make sure that we are correct. So let's divide out. Kilograms divides with kilograms. We're left with grams. We have a kilometer cubed. Well, that's a kilometer cubed. We have a meter cubed. Well, that goes out with a meter cubed. And we're left with centimeter cubed. So we have centimeter cubed in the denominator. So our density is 0.286 grams per centimeter cubed, which certainly is less than the density of water, which is 1 gram per centimeter cubed. Therefore, we know that Hyperion would float. Now this makes sense because if you take a look at Hyperion, it looks very icy. There's a lot of ice with the Hyperion and some rock, but it's mostly ice. Now, in reality, the true answer for the density of Hyperion is 0.554, somewhere in there, grams per centimeter cubed. So we're off by half. And that's because we treated this object as a cube, and it's clearly not a cube. But for the most part, we found what we needed to find. The density is less than the density of water, and Hyperion would float, which is the correct answer.